All right, we're going to get started. So today I'm talking about my experiences building a company called Segment. Who here has heard of Segment? It used to be called Segment.io. So they're based in SF, and there we go. And so basically they call themselves the Customer Data Hub. And what they are is they give you a single API that you can call to collect customer data and then send that to hundreds of different tools like analytics, marketing, and data warehousing. And we also provide features like replay. So for instance, let's say you're sending your data to Google Analytics and you do that for a year, and then a year later you want to start using Mixpanel. But the issue is that you'll lose that historical data. So we have this feature called Replay, which will replay that whole year of data, so you have your history. And the next phase of Segment is partnering with companies that we call data sources. So for instance, one example is Stripe. So like, let's say you're using Stripe and you have all your accounting info and everything in there. We're working, like the next phase is being able to, with like 2 clicks, integrate your Stripe data with something like Mode Analytics. Mode Analytics is a service that you can send data into, and then you can run SQL queries on that. So you could send your Stripe data into there with 2 clicks and then run queries on it. So yeah, so far we've handled around 1 trillion events, and we're doing more than 150,000 per second. All those events were actually counted by hand with mechanical turk. I'm just kidding. And yeah, it's not like we're handling all those events and dropping a bunch of them or anything like that. Like I think last year with Google Analytics we had 100% delivery rate, and usually we have 100%. If we don't, it's usually the integration's fault. So my name is Jeffery, at Travis Jeffery. Sometimes you'll see that face on GitHub because I maintain a lot of projects. Like Mocha, which is this node testing framework. TimeCop, which is a Ruby library that you can manipulate time. You usually use it when you're testing things that have to do with time. So you could be like, what happens when I run this in 3 days from now, and so forth. Yeah, I bounced around doing a lot of different disciplines. So yeah, previously, I actually don't work at Segment anymore. So I previously worked at Segment. And before that, I worked at Basecamp, where I was working on server-side stuff, but primarily working on revamping how they did mobile stuff. So if you remember like 3.5 years ago when their mobile apps were really crap, and then they got pretty good around 3 years ago, that you can thank me.
You still kill batteries though.
Well, can I say, I don't work there anymore, it's not my fault. So yeah. Right now, I'm working on my own startup called Stash. It's a personal mobile finance tool. Ooh, hello? There we go. It's kind of like what Mint would have been if they hadn't sold into it and really whatever they did there. Not great. So yeah. Hello? Is this still good? Okay. So yeah, I'm talking about scaling Segment today. So yeah, like I said, we're processing 150,000 events per second. Some of our customers include DraftKings. They're like betting site. When they added us, they added us like right when football season was starting, and they had like 300,000 to 400,000 signups per day, and we were handling all that analytics data. Some other customers are like Foxtel, Intuit, Atlassian, DigitalOcean, Condé Nast. Those are some others. So today we're going to be talking about these things here. So like queues and Kafka, microservices, automation. So this is Terraform and Docker, and that's Q from Star Trek. So yeah, queues. So at the beginning of Segment, we used RabbitMQ, and we used that until we had to scale up, and then we found out how tough it is to scale up RabbitMQ. It has a lot of nice tooling around message delivery and everything, but it was tough to cluster and scale. So we looked for a new queue. This was around January 2014. And we looked at a few different systems, including Garner, Redis, Kestrel, Kafka, and more on Kafka soon. Each had different delivery guarantees, but none were both scalable and simple, which were the criteria that we were looking for. Then we found NSQ, and here we are, around 1 trillion messages later. NSQ worked really great for us. It's super simple. It has a lot of nice tools. Like they have a nice admin UI, and they're really great. But that being said, today, if I needed a queue, I would use Kafka. So that's what we're going to talk about today. So Kafka. It's publish subscribe messaging, rethought as a distributed commit log. It's fast. It can handle a single broker, which is like a single instance, can handle hundreds of megabytes of throughput per second, reading and writing, thousands of clients. It's scalable, so you can have a single Kafka cluster running your whole data hub for your company. So it was built at LinkedIn, and I'm not sure how many clusters they had running there, but it might have been even a single one. But it's basically infinitely scalable, and you can transparently expand it without having downtime as well. It's durable, so compared to NSQ, which will put things in memory by default, and then once it runs out of memory, it'll then start writing things to disk. Kafka will just write everything to disk. And so then you prevent data loss, and each broker can handle terabytes of data. You can just keep adding storage to it and not worry about performance issues. It's distributed. It's very modern as a cluster-centric design. One issue with Kafka is it is a little bit more complex to run operationally, since you need to have Zookeeper to run discovery and everything like that, and run and manage some metadata and so forth. So this is how, if you know have you guys worked with queues and everything? So basically, like with a queue, you typically have this thing called a topic, right? So like a topic is some category of data. So for instance, with segment, we're handling events. We could have a topic for events that come into our system, right? And this topic, with Kafka, you can split that topic into various different partitions. So this is basically how you parallelize and scale up Kafka, is with these different partitions. And the nice thing about Kafka is, compared to NSQ, for example, which doesn't have any ordering guarantees, which is a big issue at Segment, because we're doing analytics data, right? And so some of our integrations need to have ordering. So for instance, let's say an integration tracks session data, for example. And what happens is a user sends an event to us, and it says that the user logged in. And then the subsequent events, they could be something like user bought cookies or something, right? And that data needs to be associated with their session. So that's basically a bug that we can't fix due to NSQ, but we could fix with Kafka, and at some point Segment will probably switch to Kafka. Each of these are immutable. So every time you write to Kafka, it just appends to one of these partitions. And typically these would be written round robin, so that each partition is sort of at the same size. And each log, each one of these partitions, you can configure them to be as long as you want. Or what Kafka calls data retention. So for instance, let's say you want to get rid of data that's older than 1 day. You could configure Kafka to do that. It's built in the JVM, so there's a ton of configuration options. And or you could also set it to start deleting messages when you hit a certain byte size, for example.
So that assuming that they're finished messages, or jobs, or
it'll get rid of them, yeah. Like when, sorry, say that again?
so that's assuming that they're complete messages.
No, not even if they're completed. It'll get rid of them, yeah. So this is how the consumers are set up for Kafka. So for each consumer, there's metadata that tracks what position you are in the log. So let's say you could have a consumer that says that you've read up to 4. That's how you would know, basically. But Kafka doesn't care in terms of retention. And so typically the way you would read it is you'd read it linearly. So you'd read like 0, 1, 2, 3, 4, and so on. But you could, sorry, I'm flipping back and forth. But you could read like 9, and then you could go back to 0, and then go to 4, or whatever. It doesn't matter. As long as the log is still on disk, you can still read it. So yeah, queues, we've been using queues since the beginning of that segment, and they've been fundamental and key for us in our success. They've helped us with our availability, that's for sure. So they keep things simple. So most of our infrastructure at Segment most of it are workers that will read from a queue, do some processing on it, and then act that back on the queue, put that back on the queue, or store that or something. So you don't have a lot of like dependent services that like a complex graph of services or whatever. So keeps things simple that way. It's also great for experimenting because you don't have dependencies. You can just read from the queue and then do whatever you want, and then you're good to go. It's nice in that way where all you have to do is consume from the queue, and then you could, let's say you want to replace a worker, like you have some idea on improving performance, or like you want to try out some different tech or something. It's great for that without affecting the rest of the system. So sometimes when you start to use a queue, you have to change how your system works or how your product works. And so, for example, with the first version of Segment's API, the way it would work is that an API request would come in, and if the valid was okay, then we do some validations on it, and then we respond back with a 200, right? And if the data was bad or was invalid, then we'd be running the validations, and we'd let them know that it was a bad request. And what ended up happening to us was that since we were all our stuff was made on Node, was that at one point we got to the scale where we couldn't keep up with the amount of JSON. So when you parse JSON, it blocks Node's event loop, and so basically we started timing out to requests. So what we did instead was, to fix this, was that we put in front of that node service, we put a go service. And what it did was it would do some very basic validation checks, like basically just that the JSON wasn't too big or something. And then it would always respond back with a 200. And yeah, so this helped us fix that scaling issue with handling all these events. And to handle that, is this one? I don't know if this is going to play. But anyway, to fix that, we ended up basically putting the errors in the UI. And I don't know why that's not playing. All right. So yeah, so that's basically one way we got around that. And it ended up being better. It kind of sucks that it's not showing because it actually shows more information. But yeah. Whoa, what is going on with this thing? Whoa. All right. Yeah, another change I often to do as you scale up is you'll have to add limits on everything. So, for instance, like I was saying, like adding limits to the size of the JSON that they send you, or maybe you have to add some other limits or something like that. that's another thing too that you'll have to do to make sure that your whole system doesn't get bogged down. Okay. So yeah, tons of reasons to make Fuse the backbone of your product. Durability, availability, adaptability. Customers love, and they love availability and everything. You have to think outside the box sometimes and be creative. Like, a lot of times you'll see, like, I've experienced like working with other companies, like helping them scale. They're very like hard-headed about scaling issues. Like, they think that since like the product worked for 10 people, it should now work for 1 million people or whatever, right? And that's not always the case. Like, sometimes you need to rethink what you're doing to make it work. Microservices. So the first sort of like microservice thing that we wrote was that Go service, which was like the front end, or which we called the tracking API. It was like the frontmost, the part that when you call like API.segment.com, that's the service that you hit. And then we started to go really deep dive into services. So today there's over 200 microservices that we have. And they've been really great for keeping us flexible, scalable, and making things easy to monitor. So one thing that microservices help to do is make things efficient. So for example, like if you're trying to scale up a monolith and you have one part of the system that is really eating up resources, to scale that up, you have to make a copy of the whole monolith, right? And then let's say that monolith is doing a lot of things, then you're going to have some waste because you're going to be running that on probably a big instance or something, right? Meanwhile, with a microservice, you could take that service out and then run it on some expensive hardware, and then everything else could be on cheap hardware. One example from Segment is, like, for instance, with our integrations, right? So we support Google Analytics, and Google Analytics gets way more traffic than, let's say, like some random other analytics service, right? And so we can add more resources or add more instances to that Google Analytics integration while using the cheap stuff for someone else. So better visibility. All battle-tested ops tools are built around the concept of processes, hosts, and drives. So like htop, sysdog, iftop, ps, ping, and so forth. Usually people think it's the opposite. Like, this is what I think a lot of people think about when they think about debugging or trying to fix an issue with a microservice. But this is sort of how I think of it. Like, with a microservice, you sort of have like, you know exactly where the issue is, right? Because it's kind of like a dashboard where each specific service is telling you if they're working or not, right? Whereas a monolith, it's more like this, right? Like, something's wrong, and now good luck. Like, here's the tracer, go trace every function call in your app, and good luck. Whereas like, with a microservice, it's like, if this is a car, it'd be like your muffler is clogged, and then you go to your muffler, and then you unclog it. And like, here's an example from Segment, right? So like, each worker is doing one specific thing. So here we have it here, like API forwarder, and we know like something's going on. It's not getting through the queue, and then you know exactly where to look. It's like API forwarder. That's the microservice I'm going to go look at right now. And let's say that you had, for instance, like let's say you were having an issue with billing. Like let's say you had a billing service, and that billing service, all it did was like talk to Stripe and then store some information in its own database, right? If there was an issue from that, it'd be really easy to go look at that. Number one, because the size of the code base is going to be really small. And then number two, it's only doing like two simple things. Like it's talking to its own database, and then it's talking to Stripe. So if there's an issue, there's like a couple things you have to look at. Whereas like with a monolith, it could be anything, right? Like it could be Could be like anything in your database, because it could be something that's contending or anything, right? Like, so. Another benefit of using microservices is that you can use the right tool for the job or the right technology for the job. All our infrastructure stuff at Segment is written in Go. Some higher level stuff and older stuff, we still use Node. And those services are owned by teams that they're focused on using Node and they're not as strong with Go. And our benefit of using Go with the infrastructure stuff is performance and yeah, mainly performance. And one example of that would be, let's say you're tracking like session data, right? I worked with this one company that basically had this huge Mongo table full of session data. And basically they're using it as a key value store. So basically I went in there and I was like, okay, we're gonna replace this huge table with a single Redis instance, and then we're gonna add a TTL to these keys that we write in, because sessions only last for like 1 or 2 days, and then we're done. Like, we don't need to worry about Mongo going down or anything like that. So yeah, sort of going back to the last talk about deploying to production. I vividly remember the first time I brought down Basecamp after basically a one-line config change. And similar things have happened at Twitter, and I think I heard a missing semicolon once brought down all of Netflix. With microservices, you can make a change to a single service and deploy it independently to the rest of the service. That means that changes are released faster because they're low risk and small impact, and they're less impediments to getting software out the door. So that's another reason for going with that. So yeah, so you save money, you increase visibility, you can iterate faster because people aren't worried about having everything go down, and you can play around with different technology and different solutions. And personally, I find it a lot less stressful to just write a new service or extend an existing one, because there's a lot less code and there's a lot less things that can go wrong with changing that small code base rather than a huge app. So yeah, microservices are key, in the words of, what's his name on Snapchat? Yeah, DJ Khaled, yeah. Oh man, this thing is just, oh wow. Stop. I think I should probably stop using that. Alright. Okay, so next section is about automation and sort of how you hook these things together. Oh my god. Yeah, I'm done using that. I think it's... Yeah, I don't know, maybe it's like the Wi-Fi? Sorry about that. What the? Sorry, that's one thing. Does anybody know Keynote? Yeah. Maybe I'm gonna avoid that one slide. Alright, so we're just gonna do it like that. Oh, sorry. All right, so I'm going to go real quick here. So we use Docker. Docker describes how each of our services runs. This made it great for us because we used to have like these really complex provisioning scripts and AMIs and everything. But this way, anyone on the team could just run Docker run. It's a command provided by Docker. And basically, it was one way for every service to run a service. So this is how we had things set up. So you do a git push. That would then trigger build in Circle CI. Once that, if everything passed and was okay, and also the Circle CI could also boot up any services that whatever you deployed depended on. So like let's say you had your app and it depended on like Redis or something. Circle CI could use Docker Compose and then boot up your whole system. If that was okay, then it would do a Docker push. So Docker Hub is like Docker's service that contains like your Docker images. So then what would happen is we had a Slack command, /deploy, set up in Slack. What it would do is it would update ECS, which is this elastic EC2 container service provided by AWS, which would then schedule whatever you deployed to start running. So super easy. This is how we had things set up in AWS. Every environment had its own account. So we had a stage account, we had a prod account, we had a dev account. And this was really great because number one, we basically had no configuration, or we had like very little configuration, right? Like rather than saying that the stage DB or like the stage app was at like stage-.db, blah, blah, blah. And then whenever you booted up the app, you had a configuration for that. We just had, by having these in separate accounts, each one could just be at its own, at the same address, right? So like the DB could be at db.segment.local. And that was the same for stage, prod, and dev. And then this was also really great in terms of security. So like let's say, or security or like keeping things running great. So like imagine if you had someone, you had like Bob on your team who accidentally dropped the production load balancer, right? Then Bob doesn't get access to prod anymore. He's just gonna stay on stage and dev for a while. Yeah, so that was great. So yeah, Docker and ECS describe how to run each service, and then we use Terraform to glue them together. And Terraform is basically like infrastructure as code. So if you use CloudFormation, it's kind of like that, but doesn't make you want to pull out your eyeballs looking at it or using it. So this is basically what a Terraform. It's like a declarative text file that describes the thing you want to set up. So like they also have like implementations for Google Cloud Platform and so forth. So here we're describing an EC2 instance that we call Bastion. We can also have variables. So we have this referencing this variable that's from up there, and we're saying which region this thing is going to be in, which distribution it's using, and so forth. So you can also do things like iteration. Like you can set a counter in here and be like, we want 5 instances of this thing. Iterate over that and name them like Bastion dash OX for the number of the thing. So it's pretty great. And the other nice thing about having your infrastructure as code is that, let's say you want to go through and you want to do like a sweeping change on your infrastructure. So like for instance, you want to change how your ELB drains timeouts, for example. Like when we wanted to do this, and to do that, all we had to do was a find and replace, and then run Terraform apply, and then that updated everything on our infrastructure. And then 2 minutes later, we were done. And it's also nice because we have this checked into a single repo. So one repo has all of the Terraform scripts for our whole infrastructure. And now this gives us like a timeline, and we can see everything that has changed to our infrastructure via the commit log. We use Datadog. It's pretty slick. All our metrics and monitoring went in there. Every service that we deployed had metrics. we use those for alerts, and then that would email us and then message us on Slack if there was never an issue. Datadog integrates with AWS really well, so you can visualize instances on how they're going to use if they're running hot or so forth. So for instance, this one isn't getting used as much as like this one, and it's really easy to see. So yeah, monitoring is essential, and keep track of everything running in prod. It helps you see the big picture. Metrics help you see the small picture, and you can use them for alerts. Metrics also help with communicating things with support. So for instance, let's say support is saying, users are saying that their data is lagging or something, or it's out of date, right? Like, you have a timeline on when that's going to be fixed, and you can be like, here's the dashboard with the graph of the lag. That's all you need to know. Automation helps remove a lot of the pain that people imagine when using microservices. So yeah, just to recap, views are awesome, and you should check out Kafka. Microservices have worked great for us. Don't feel like you need to switch though, because it's like the cool thing to do right now. The monorail app at Basecamp, it worked really well as well. And automation will help you to be faster and make your life a lot better, a lot more productive, and you'll be a lot happier. I guess I'll cover this. So basically, these are like the tools. Like if I was gonna have a scaling fight with someone or something like that, these are the tools that I'd bring with me. Go for like my programming language. Great with concurrency. You can distribute binaries. Kafka is my queue. Redis is, people think of Redis as like a key value store, but it's a data structure server. So you can use it for all kinds of things. I've even written like a time series database with Redis. Nginx is a load balancer. You can hammer Nginx with like 15,000 requests a second, and it'll be doing like, it won't even be doing like 15% CPU on a small box. Elasticsearch, Elasticsearch is way underrated. Like, a lot of people use it for logging, and you should use it for logging because every logging service that I've used is really crap. Especially, I'm not gonna throw any. I used this one service, and it was really like every service that I've used for logging has been crap. In my opinion, you should just set up like ELK, which is like Elastic, Kibana, Logstash, and usually each logging service is built on Elasticsearch anyway, and so this is just much easier. But with Elasticsearch, you can also use it for things like, let's say you have dynamic data that you want to index. You can put that in Elasticsearch, and it'll automatically index it for you. Let's say you have, it's also really great for analytics stuff because it has a very powerful analytics engine. For instance, at one company, we replaced this like 5-minute long aggregate query in Mongo with a query in Elasticsearch that took a few seconds. And Postgres can do pretty much everything at this point, but you can also check out some extensions called CStore, which adds columnar support to Postgres, and another one is called Citus, which is, they're now working on making Postgres horizontally scalable. They are earlier on though, I've tried them out. They do have some issues. So yeah, thanks for having me, and I hope you guys found this useful, and if you guys have any questions, or if you, yeah, I'd love to hear them. Yeah?
Yeah, so I was wondering how you got around Docker builds, being like slowing your development down.
Yes, okay, so I would not use CircleCI right now. The only one that I know of that provides caching support, it's like you need caching, right? Is CodeShip. So use CodeShip, they have caching, it's fast.
And what about locally? Like, you mount your file system, or?
It depends on what I'm doing. There's a lot of tricks. Like, let's say you're using Node. There's like a way. So like one issue with like Node is like you do npm install and that busts your cache. So there's a way you can get around that. It's complicated. It depends on the case, but like basically you just need to have it so that your node modules doesn't change like anytime you make any change. So there's just a whole bunch of different ways around that. Yeah.
So if you use Terraform, have you seen Packer versus Docker? Because like you can use the same Packer file to Docker as the like post-processing step, the same Packer.
Packer?
It's the HashiCorp like bigger.
Okay. Oh yeah. I haven't looked into it too much. I think when I looked at it, I think it was like sort of early days. It seemed like. So that's basically why I hadn't used it. But they'll probably figure it out. Like all the HashiCorp stuff is pretty awesome. So.
And then when you're doing your Docker microservices, you're wrapping them all up on the same host. So each microservice essentially deploys all of its containers to the same host.
Yeah. So the way I don't have a real good picture here, but it's okay. So basically, with ECS is the way you set things up is that you have clusters, right? So, and then those clusters have services. So for instance, you could have a cluster that would be like the database cluster or something, or like a general cluster or an API cluster, and then you'd have services in there, and then those would have instances, and then your scheduler would know that basically there's a task definition that says that it belongs to a certain cluster, and then that's how it knows where that thing is going to be scheduled and ran.
It's like another task and all that stuff. The thing that I jumped off for Docker for was scalability. It's like it was easier to put up an auto-scaling group or a bunch of AMIs that I built with Packer than it was to like get the like actual cluster instance to scale and then inject all the Docker containers using Amazon.
Yeah, so it's this is around like scaling on ECS. It's Amazon, right? It's Amazon thing, right? So you can set up a scaling group for it. So
But that's just setting up other hosts.
it will also you can also have it update the task as well. Yeah. Like there's like a task count. So that says how many you want to run of this
And
thing.
it's just based on how many hosts are in the cluster, and then it'll just.
And you can also do things like you can set up like a CloudWatch thing. So like you could run what's a Lambda function. You could run like a Lambda function that runs every minute, looks at the CloudWatch CPU and everything, and then increments the count or like adds another instance or something.
So is Terraform providing like an abstraction to like an Amazon API? So you don't think there is like an Amazon API for like managing all the stuff?
It's basically like it's basically kind of a replacement for CloudFormation in a way. But they also have like GCP. It's not just AWS. Like you could also use it. I think they have Azure support as well.
But they're abstracting it too.
Yeah, basically, yeah.
How are you achieving the zero downtime during deployment if it's not related to few consumers? It's something web-based.
Yeah, so ECS handles that for you. It does blue-green deployment. So basically, it will drain things down, but it will keep however many you can like set a percentage of like how many instances you want to keep running, and then it will just flip them over. So ECS handles that for you with blue-green deployment. Yeah.
Can I ask you about your CI situation for 200 microservices? When you do a CI like integration test, do you spin up the whole system? And all the package services?
It really depends. Like we won't spin up the whole thing. It really depends on the thing, but as little as possible. So it really depends. As little as possible. It just like whenever it makes sense to spin up the thing and like actually hit it, then we'll do it. Otherwise, a lot of cases with like Go, you'll just write an interface, and so yeah, you'll write an interface, and then like for your test, you'll just use a temp file rather than hitting disk, or like use something that just mocks out the database call rather than actually hitting it. Yep.
When you guys mentioned things like Go, what monitoring do you have to figure out that those metrics
you want? Well, around the time like we had the profiler, so you could like attach a profiler to it. Profiler kind of sucks, but like you just knew basically like I don't know. like we just kind of knew, like we had a lot, like we had all kinds of stats, like I was saying before, about like when or how we're handling requests and like our timeout rate. So like that was a big big thing to look at. Was like, we're timing out. Why are we doing this? Like it was I don't know. It was pretty obvious. That particular problem was like, it was clear. But yeah, stuff like that, like the timeout rate and like this how we're responding and everything, like things like that helped a lot. Yeah.
Yeah, so for Kafka, when you're configuring it, are you able to?
Can you say that again? I didn't hear you.
Yeah, so for Kafka, when you're configuring Kafka, when you're taking things off the queue and you acknowledge it, does it get taken off the topic queue? Like
No, so it'll stay as long as you have it configured your retention period. So basically, the two ways that you usually configure that is either by the time duration, so like after a day, delete them, or by the size, like how many total, the size it is that you have stored on disk, so that you don't run in disk space. So like if you have like 1 terabyte of disk space, like maybe you'll set that to like 900 megabytes, and then it'll delete it. Which is awesome because like, if you like, let's say you consume this thing once, but then later on, I don't know, something like totally messes up and like your Elasticsearch database goes down or something, then you can just replay it. Like you can just set your offset to go back to 0 or whatever, and then do it again. Or like if you want to have something else that wants to read from it. I think that's it.
Thank you, Travis.
Yeah. Thanks.